Close your eyes for a moment. Imagine a computer. That doesn't think like ours. Not in ones and zeros, not step by step, but all at once. Welcome to the world of quantum computing. For decades, computers followed simple rules. Zeros, ones, off, on. Every photo you upload, every message you send, every video you watch, all of it is built on these two numbers. But what if a computer could be both 0 and 1 at the same time? Sounds impossible, but nature plays by different rules. In the tiny world of atoms, particles don't choose just one path. They exist in many states simultaneously. This strange behavior is called superposition, and when particles become mysteriously linked, changing one instantly affects the other, no matter the distance. That's called entanglement. These are not theories. This is how reality works. And scientists asked a dangerous question. What if we build computers using these rules? Instead of bits, we created qubits. A bit is either 0 or 1. A qubit can be both at the same time. 1 qubit can do more than one calculation. 2 qubits can do 4. 3 qubits, 8. As you add more qubits, the power explodes exponentially. Scientists worked for decades, failed, tried again, and again, until one machine changed everything. Then came Google. In 2019, they revealed something unbelievable. A quantum computer called Sycamore. 53 qubits, supercooled, floating near absolute zero, colder than space. This machine performed a calculation in 200 seconds, a task so complex that the world's fastest supercomputer would take 10,000 years to finish. Not days, not months, 10,000 years. This moment was called quantum supremacy. For the first time in history, a quantum machine did something no classical computer could. What did it calculate? Random numbers. Sounds useless. But that wasn't the point. They weren't normal random numbers. They were so complex, no classical machine could ever predict them. It proved something deeper. A new era had begun. And before we go further, if you're enjoying this story, hit like, share it with someone who loves science, and subscribe to this channel for more mind-blowing stories like this. Now, let's continue. So what can quantum computers really change? Medicine. They can simulate molecules exactly, helping scientists design new drugs. Climate. They can model Earth's systems with extreme accuracy. Energy. They can optimize power grids. Artificial intelligence. They can train models faster than ever before. Even cryptography. The same systems that protect your data today could become breakable. But quantum computing isn't easy. Qubits are fragile. Heat, vibration, even cosmic rays and can destroy calculations. That's why quantum computers live inside giant refrigerators, protected like ancient treasures. Google isn't racing for speed. They're racing for stability, for error correction, for real-world use. Because the true power of quantum computing hasn't been unlocked yet, we're standing at the edge of something massive, like the first days of electricity or the birth of the internet. Most people don't see it, but it's happening right now. This isn't science fiction. This is the next chapter of human intelligence. A machine that doesn't just calculate, it explores reality itself. The future isn't coming, it's already here. Welcome to the quantum age.